Hello, it's Andrew with M&A Softworks. So, what has been going on? Well, in the background, you'll see I'm basically reassembling the the whole project into a new Unity kind of project file. Now, this is a pretty extreme thing to do. It takes a while. It's a lot of extra work. So you might be asking, well, why are you doing it then? And the answer is kind of simple in one hand, but on the other, it's not really. So, this game, like all space games, in fact, any game that happens on a very large scale, where you can go very far in all directions, has to deal with this problem, which is that your game engine, it only stores so many digits of your distance. So, yeah, I can go out, say, 10 billion meters from the center of the world, but the game engine isn't going to store all, each digit of that number plus a whole bunch in the decimals to give proper accuracy. Um, and because these numbers they're floating point numbers, you're basically given a set amount of digits. In the Unity game engine, you're given 7 digits. Um, and the more you need to express how far you are on the left-hand side of the decimal point, the less accuracy you have on the right-hand side. That is to say, if you're 1,000 meters away from the center of the world in Unity, you know where you are down to the millimeter, right? Because you're using 4 of your 7 digits on the left side to express 1,000 meters away, and that gives you 3 digits on the right side, your decimeter, centimeter, and then your millimeter, and you know where you are within that millimeter that's given. Um, but as you get farther away, you lose more and more accuracy. So when you're 10,000 meters away from the center, you only know where you are in the centimeter now. And then when you're 100,000, you only know where you are in the decimeter. And then, if you're 1,000,000 meters out, you don't know where you are within the meter. All you know is you're in this 1 cubic meter area. And the problem is the engine uses these distance numbers to calculate physics, to calculate how to draw the meshes, the 3D models, how to put the texture on those. Um, so it's a pretty big issue when you can't nail down where you are within a meter, because the game doesn't know when to start a collision within the meter. It doesn't know how to draw the mesh within the meter. So you get all these crazy issues. The farther you get from the world, the craft will start jiggling and shaking, and it just kind of like falls apart and becomes a three, like a modern art piece. It's really ridiculous when you push it to the extreme. So the common solution to this, as far as I can tell, is to basically just define the center of the world as the player. So when you're moving, it's not actually the player that's moving, it's the world that's moving around the player. So that sounds great and all, but how do you go about implementing that? Well, it's not exactly easy, and it's not something I can practically do currently. So I've gone a less efficient route, but it will work for the time being. I will have to remember to come back and replace this with a system that works more efficiently and it's just better. But now what I currently do is I basically just have this line of code that goes, hey, and it checks the position of the player, or really any game object. You could set it to check the position of anything in the world, but it checks the position of the player, and it says, hey, if the player is beyond this distance from the center of the world, then just move the whole world over however much is necessary to put the player back in the 0, 0, 0 spot. Um, so, if you fly more than 100 meters away from the center of the world, say, then the second you cross that 100-meter threshold, you get teleported back to 0, 0, 0, but everything else gets moved in equivalent distance in an equivalent direction. So from your perspective, it looks like nothing happens. Um, I'm sure this is going to cause all sorts of performance issues, so we'll have to see what we can do with that. Now, in the background here, you can see me kind of messing around with the shadows. So I was having some issues, but one of the nice things about moving everything over to the new version is I was able to actually get the shadows to work correctly. So now, I haven't done any testing yet, so this is very kind of preliminary, but I did not say that word right at all, but theoretically these shadows should work correctly, so when you fly behind the planet, you'll actually be in darkness, like real life, instead of magically being lit up through the giant planet. So that's a nice benefit. But it comes with a few costs. Mainly, we're going to lose the atmosphere that we just got. So the way I render the atmosphere, it basically relies on the material for the atmosphere being able to be seen from both the inside and the outside. And the new render pipeline that I have to use, which I promise I'll get to why I'm using a new render pipeline, that does not allow it. It doesn't allow you to have things render from the inside. So I'm looking into ways to fix that. But why? Why any of this? Why do I have to render, or like, why do I have to use a new render pipeline? Why do I have to recreate the project? Well, Unity doesn't have a way to switch render pipelines, so if you want to use a different one, you have to just recreate the project, which is why I'm doing that. But as to why I need a new render pipeline, there's a second issue that's tied to that distance accuracy issue, and that's the camera. Things beyond a certain distance will get all flickery, and they'll, kind of like seemingly, as I like to say, they'll phase into a different reality. Like they'll just melt away, it looks like, and it's really weird, and it completely pulls you out of the game, and you just go, oh, that's a bug. So the way to fix this, though, is, one of the ways to fix this anyway, is to have multiple cameras. Because instead of having one camera that has to use a 7-digit number, or, whatever, to record each vertical position away from the camera, because it basically splits up, the area the camera's looking at gets split up into little slices, like a loaf of bread, and each one gets numbered. And that kind of numbering determines how far it is between each slice. Well, the number it uses is the same number of digits as the distance. In terms of that, it's also 7 digits. So if your camera is set to render a massive amount of area, you'll actually start to lose accuracy in what you're rendering, and that's why you get that flickering and that glitchiness, especially as you get towards the end of the kind of view frustrum, as it's called. So the solution to this is, instead of having one giant camera, you just use a whole bunch of different cameras and you layer them together. So I have a camera that renders from 0.1 meters away to 10,000 meters away, and then you have another camera that renders from 10,000 meters away out to, however far you want, and so on and so forth, and you layer them on top of each other. This is called camera stacking. The issue is the lightweight render pipeline, which is the current render pipeline that the game, well, it's the render pipeline that the in-development version of 0.3, which is what I was working on, was using. It does not support that camera stacking. So I had to go back and switch over to the standard render pipeline, which is what I was originally using, like in the current, most recent version of the game, was being used. And I switched over to the lightweight render pipeline because that gave me all sorts of additional graphical stuff, and now I have to switch back because of this issue that only recently became apparent. So that's why I'm going through this whole process in the first place. Thankfully, though, by taking care of these issues now, I won't have to take care of them in a future update, which is what I was originally planning. So this will put me a full update cycle ahead of schedule, which is awesome, and allow me to move things faster. It will very slightly delay the release of 0.3, but it'll allow me to concentrate a lot more on building a more permanent system when I add in the voxel kind of block system that's going to be coming in the next update. And once that's in, the game will finally begin to actually resemble something close to what the final version will be, which is pretty cool to think about, that we'll finally start to get there. Now, that voxel update will probably be the point at which we can say that this is no longer just pre-alpha, but it's kind of moved into alpha, and the game will be more representative of its final form, and it can actually be something that I can go to YouTubers and say, hey, here's a key to the game, you want to maybe check it out. But we'll still have a whole lot of work to do before the game is done. Anyway, this has been Andrew Simon with M&A Softworks, and I'll see you next time.